Hi students, today I am going to teach the next topic in Unit 3 Laws of Motion, that is particle moving in an inclined plane. Particle moving in an inclined plane. First you need to understand what is the meaning for inclined plane. A plane, it is making the angle. It is making some angle. That plane is called inclined plane. Okay students? So inclined plane means here it is not a flat surface. Here it is making some angle, that is called inclined plane. When an object of mass m slide on a frictionless surface inclined at an angle theta, the forces acting on it, the forces act on the body, decide the one acceleration of the object, two speed of the object when it is reaches the bottom. Okay, so the forces acting on the object, it decide the acceleration of the object, then the speed of the object when it is reach the bottom. The force acting on the object is, here the force object on the object is, one is downward gravitational force, the another one is the normal force is acting, perpendicular to inclined surface, already you know that. Okay, there is a two type of forces acting. One is gravitational force is acting towards the downward direction, the normal force is acting perpendicular to the surface. So to draw a free body diagram, the block is assumed to be a point mass. Here the object is assumed to be a point mass, that is not a vector m. Since the motion in the inclined surface, we have to choose the coordinate system parallel to the inclined surface, that is shown in figure. Okay, so according to this, here we take the downward force, that is a gravitational force is acting, that is mg is acting in downward direction. The normal force is acting perpendicular to the surface of the object, that is not a vector n. So here this mg, it is resolved by the two components, that is mg sin theta and mg cos theta. So the free body diagram for this object is considered as a point mass. Mg is acting towards the downward direction, the normal force is acting perpendicular to the surface. The gravitational force mg is resolved into parallel component mg sin theta along the inclined plane. Okay, it is resolved by the parallel component, that is mg sin theta is parallel to the surface of the inclined plane, and the mg cos theta is another one component, is perpendicular to the inclined plane, Okay, so for the inclined plane it is perpendicular. Note that the angle made by the gravitational force mg with the perpendicular surface is equal to angle of inclination. Okay, so here the angle between the mg and the mg cos theta, it is making the angle is theta, that theta is also equal to the angle of inclined plane theta. Okay students, right? That is shown in figure. You notice that? So it is the method how we can take the values of theta. Okay, so in the triangle ABC, so to understand this concept, we are taking from the point, we consider this is one of the triangle, that is ABC. We extend the mg and we make one triangle, that is ABC. So the total angle is, for the ABC, the total angle is 90 degree. So the angle of BC and AC, and then the angle between the AB and AC is totally 180 degree. So here the angle is 90 degree means we can write what is the values of the theta 1. Theta 1 is equal to 180 degree minus 90 minus theta. So 180 degree 90 minus theta means it is equal to 90 minus theta. But from the figure we can write that theta 1, theta 2 is equal to 90 degree, because we know that the mg sin theta and mg cos theta, it is perpendicular to each other. So we know that the theta 1 and the theta 2 is 90 degree. So from this we can write what is the values of the theta 2. Theta 2 is equal to 90 degree minus theta 1. So 90 degree minus theta 1 means already you know the values of the theta 1, that is 90 degree minus theta. It is substitute in this equation means 90 minus 90 is minus theta, sorry, plus theta. So we can write 90 minus 90 cancelled. So theta 2 is equal to theta. Theta 2 is equal to theta. So here that angle between the mg and the mg cos theta, it is equal to angle of inclination theta. It is shown in the figure. There is no motion along the y-axis. Apply Newton's second law in the y direction. Okay. So when the object is moves on the inclined plane means there is a motion along the x direction. There is no movement of the object along the y-axis. Only the object is dropped from moves from this point to this point. So there is having the displacement along the x-axis. There is no motion along y-axis. So there is no acceleration along the y-axis. Applying Newton's second law, we can write what is Newton's second law, that is F is equal to ma. So from this we can write that is minus mg cos theta j. Here it has acceleration. There is no motion along the y-axis, so along the y-axis it has acceleration, that is mg cos theta. So it is along the opposite directions of the y-axis, the mg cos theta. So it can be written as minus mg cos theta j cap plus n is acting upward direction, so that is nj. Along the y-axis we apply the Newton second law. So minus mg cos theta j cap plus nj cap is equal to 0, because there is no acceleration, that is F is equal to ma. So the Newton second law is applied. There is no acceleration along the y-axis, so we can write minus mg cos theta j plus nj is equal to 0. By comparing the components on both sides, we can write n minus mg cos theta. We take the j vector, j cap on outside. We can write n minus mg cos theta is equal to 0. So from this we can write n is equal to mg cos theta. So the magnitude of normal force exerted by the surface is equivalent to mg cos theta. So the object slide along the x direction. Applying Newton's second law in the x direction means what is the acceleration of the body along the x-axis? It is due to the gravity. It has a value as mg sin theta. So along the x-axis it has acceleration mg sin theta. So we can write mg sin theta. So we can write the mg sin theta I cap is equal to, it has acceleration. The mass of the body is m, acceleration is a, so we can write m a I cap. By comparing the components on the both sides, we can write what is the value? Mg sin theta is equal to ma. M cancelled means we can write what is the values of the a is equal to g sin theta. So the acceleration a is equal to g sin theta. There is no motion along the y-axis. So note that the acceleration depends on the angle of inclination theta. The acceleration is dependent on the acceleration is dependent upon the theta, because a is equal to g sin theta. So note that the acceleration depends upon the angle of inclination theta. If the angle theta is 90 degree, if the angle is 90 degree means what is the way? A is equal to g sin theta. Theta is equal to 90 degree means here it has a maximum values, that is 1. So we can write a is equal to g. A is equal to g. Newton's kinematic equation is used to find the speed of the object when it reaches the bottom. We know that. Okay? So from the Newton kinematic equation, we can calculate the values of the velocity. That is v is equal to u plus at. By using this, we can calculate under another formula, that is v square is equal to u square plus 2as. By using these formulas, we can calculate the speed of the object to reaches the bottom. So the acceleration is a constant throughout the motion. So we can write v square is equal to u square plus 2as along the x direction. The acceleration is equal to g sin theta. The initial speed is equal to 0. Initial speed means theta is equal to 0. Theta is equal to 0 means here there is no motion, it is at rest position. Here the acceleration is 0. So the initial position, the speed is 0. It starts from rest. Here s is the length of the inclined surface. So we can write the speed when it is reaches the bottom is calculated by using the formula of v is equal to initial position is equal to 0. So 2a means that is a g sin theta into s. So 2s g sin theta. From this we can calculate the values of the v, means v is equal to root of 2s g sin theta.